Good evening, students. Now let's see how to find the basic solution of a given linear programming problem. Okay, so first of all, here you have to see how many unknowns are there. So here 1, 2, 3 unknowns, and there are 2 constraints. Okay, so 3 unknowns and 2 equations, these 2 equations. Then means here 3 unknowns and 2 equations, so as you know, it is difficult to find the solution, or in fact it is not possible to find the solution. So what we do here, we will substitute one of these variables x1, x2, x3, one of these variables as 0. So how you have to find it out? Look at the equation, see how many unknowns are there, look at the constraints, see how many constraints are there, then difference between that. That means 3 unknowns and here 2 constraints. So 3 minus 2, that is equal to 1. Then one of this x1, x2, x3, one of these values you will give it as 0. And now to see how many basic solutions will be there. So to know that one, 3C2, this combination you will see 3C2, as you know it is 3. Okay, so there will be 3 basic solutions. Okay, then now number of basic solutions, I'll draw columns like this, it would be easier. So number of basic solution means here, as we told, there will be 3 solutions. So let's see what all they are. So I'll put here 1. Then non-basic variables, basic variables, I'll put that as equal to 0. That means here I told one of these x1, x2, x3 will substitute as 0. Okay, so they are the non-basic variables. That is, first of all, suppose I am giving this x3 equal to 0. x3 equal to 0. Now the basic variables will be what? The remaining 2. So x1 and x2 will be the basic variables. Okay, so now in this given conditions, put x3 equal to 0. So you will get there x1 plus 2x2 equal to 7 and 3x1 plus 4x2 equal to 15. Okay, so now you got 2 equations and 2 unknowns. Then now while solving this one, you need to solve these 2 equations, and while solving you will get x1 is equal to 3 and x1 equal to 1 and x2 is equal to 3. Like this 2 values you will get. Okay, so x1 is 1 and x2 equal to 3. Now next is the solution feasible? Now solution is feasible if all the calculated value is non-negative. That means here whatever values you have got here, these all are non-negative. So obviously x1 equal to 1 and x2 equal to 3, they are non-negative. Therefore here yes, the solution is feasible. Now is the solution degenerate? So as we discussed in the previous lecture, degenerate means if this calculated value contains at least 1 0, then we call that as degenerate solution. So if some of the values obtained in the basic feasible solution are 0, then we call that as degenerate feasible solution. So but here none of the values is 0, therefore solution is not degenerate. Okay, so no. Now the second solution. So now here we put x3 equal to 0. Now what I am going to do is, now I will put x2 equal to 0. x2 equal to 0 means here it was x1 and x2. Now I put x2 is taken outside. Then this is x2 can be called as outgoing variable. Okay, x2 we call that as outgoing variable, and instead of this x2, so here I will keep x1 as it is, and instead of x2 I will take x3. Okay, so x1 x2 was there. Now instead of x2 I have put x3. So x2 went out and x3 went in. So this x2 is outgoing and this x3 is, we say it as incoming variable. Okay, so now here in this given equation, we will put x2 equal to 0. This 2x2 0. So you will get x1 plus 3x3 equal to 7 and 3x1 plus 6x3 equal to 5. Now solving these two equations, you will get x1 equal to 1, x3 is equal to 2. Okay. Now again, is the solution feasible? So both are greater than or equal to 0, greater than 0 both are, therefore it is feasible. Is the solution degenerate? That means at least one of these values what you got is 0, then only it is degenerate, but it is not like that here, so it is no. Okay. Now the third condition. Third number of basic solution is third. So now what, x1 x3 0, x2 0. Now we will keep x1 equal to 0. So see here x1 x3 was there. Now I put x1 equal to 0. So what should come here now? Here instead of x1 I will put x2 and here this x3. So now here x1 is outgoing and x2 is incoming. Okay. So now in the given conditions put x1 equal to 0. So you will get that as 2x2 plus 3x3 equal to 7 and 4x2 plus 6x3 equal to 15. Solving this you will get x2 equal to, and this we cannot solve in fact, because 2x2 plus 3x3, this is 4x2 plus 6x3, both are having the same coefficients. So if you solve this one, you may get an unbounded solution. So here the solution is unbounded. So unbounded solution. So nothing of this matters here. So this is the way to find the basic solutions. Okay. So now let's see another question. See the question. Maximize the given question subject to this given conditions. So here also 1, 2, 3 variables, 2 equations. Okay. So 1, 2, 3 variables and 1, 2, 2 equations are there. So again here, like in the previous question only, find the basic solutions, which of them are feasible, non-degenerate, infeasible and optimal basic solution. All this we need to find out. So first of all, number of basic solution, like in the previous question, it is 3 unknowns and 2 equations. So 3C2. 3C2 means if 4 unknowns are there and 2 equations are there, then number of basic solution will be 4C2. Okay. So that is a way to find out how many terms will come here. So number of basic solutions here, it is 3 will be there. So first one will be, now non-basic variables, I am keeping one of this x1, x2, x3 equal to 0. So suppose I am keeping x3 equal to 0 here, then basic variables will be x1 and x2. Then while putting x3 equal to 0, the equations you will get x1 plus 2x2 equal to 4 and 2x1 plus 3x2 equal to 7. Solving this, you will get x1 is equal to 2 and x2 equal to 1. Okay. Now is the solution feasible? All the values means all the values here, they are positive. Therefore, here it is S. Now is the solution degenerate? Degenerate means at least one of these values, if it is 0, then it is degenerate. So here nothing is 0, so it is no, non-degenerate solutions here. Now value of Z. Value of Z means when x1 is 2, x2 is 1, x3 is 0, what will be the value of this Z? So I will put x1 is 2. So 2 plus 3 into 1, 2 plus 3, 5, 5 plus 3 into 0. So 5 plus 0, that is the value of Z is here 5. Now, is the solution optimal or not? So now to find whether the solution is optimal, we need to find all the other values, then only we can see whether this is optimal or not. Optimal means maximum or maximum value or not. Max, because the question is for maximize. Now the second one. Now I will keep here x2 equal to 0. x2 equal to 0 means x2 is outgoing. Okay, so when x2 is outgoing, someone should come inside, so I am taking x3 is incoming. So while x2 is going out, x3 is coming in. So the equations here, it will become x1 plus 3x3 equal to 4, 2x1 plus 5x3 equal to 7, and while solving this you will get x1 equal to 1, x2 equal to x3 equal to 1. Okay, now here again, is the solution feasible? Yes, because both the values are greater than 0. Is the solution degenerate? No, because none of the values is 0. Now maximum value, value of z will be here while putting x1 is 1, x3 equal to 1, x2 equal to 0. In the question, in z equal to what is given, you will get the value of z as 4. Now third one, so x3 0, x2 0. Now I put x1 equal to 0. x1 equal to 0, x1 goes out from here. So x2 comes in, x2 is incoming and x1 is outgoing. So the equation here, it will become x1 is 0 we are putting, so 2x2 plus 3x3 equal to 4 and 3x2 plus 5x3 equal to 7. Solving this, x2 equal to x3 equal to 2 and x2 equal to minus 1. Now here, is the solution feasible? Means whether all the values are greater than or equal to 0. So means positive or not. So here x2 is minus 1. So this solution is not feasible. No. Now is the solution degenerate? None of the values is 0. So that also is no. Now here, while putting value of z normally when it is a degenerate function, value of z we won't find out. Okay. Then here you needn't find anything here. So out of these two, this is the maximum. So is the solution optimal? Yes. And here then it will be